We pray. Dear Heavenly Father, I thank you for this day. I thank you for the gift of life. I thank you for making us wake up today. I thank you for everything you have given us. God, I thank you for bringing us here early enough. Dear Lord, whatever we are going to learn, may you bless us. May you, God, help us to analyze it and even interpret it and apply it in the examination. In Jesus' name I prayed and believed. Amen.
Amen. Thank you so much, Victor, for the word of prayer. Good morning, everyone. Thank you so much for keeping time. Today, we are going to be looking at double angle formulae. Yesterday, we started on the compound angles, and today we are going to look at the double angle formulae. Now, when they talk about double angle, the way you hear the word double twice, it means that we are going to basically look at three important trigonometric ratios. We are going to look at the sine, but when the angle is doubled, like when the angle here is, we have two. We are going to look at the cos when the angle is doubled. We are going to look at the tan when the angle is doubled. By doubling, is like when you look at 2a, you notice that it is the same thing as having a plus a. Now, this is what we call two angles, so which we call the double. The same thing with cos of 2a, which we can have here as a plus a. Now, we are going to look at the important relations. We are going to look at the important identities. We are going to look at how are these things, how can we write the trigonometric identities for the double angle. Now, yesterday we looked at the compound angles, and let me hope by now each one of us here you have a hint on these important compound angle formulas. Now, these compound angle formulas are going to be crucial. When we are working out on what you call the double angle formulas. So we are going to be applying these these compound angle formulas to come up with the double angle formulas. Take an example. We are going to start with the first one, sine of 2a. Now, what is going to happen? We know very well that when in sine of 2a, mathematically, we can write it as sine of a plus a. Because when you have a plus a is the same as 2a. But we know, yes, from yesterday's work, we know very well that whenever we have the sine of two angles, let me say a plus b, we know that this is the same thing as sine of a cos of b plus this is the same as sine of b cos of a. Now, we are going to apply. But for this case of ours, our a here is a. Our b is also b. So we are going to be substituting here, here, and here. So we are going to come and now say that our sine of a plus a is going to equal, we substitute, we shall have sine of a cos of a plus we shall have sine of here a still because our b is a, and we shall have cos of a. Now, what are you getting? Sine of a and cos of a, sine of a and cos of a, meaning that these two things here can be added because the sign in between them is addition. So members in the chat, can you quickly tell me when you have this plus this, because they are the same, which answer do you think you get? Place your answer in the chat. What do you think you get when you add sine a cos a, sine a cos a? What do you get? Relate it to what you have. Like when I have x plus x, what do you get? Whitney has said 2 sine a cos a. Tekin has said 2 sine a cos a. Anthony has said the same. Narak, Meriton, Jovi, yes. Thank you. Now here, members, we are going to end up having our answers to sine of a cos of a. And I want to bring it to your attention that whenever going forward, whenever you are going to be meeting sine of 2a, we shall be writing it mathematically as 2 sine of A cos of A. In case you meet something like, in case even if it is sine of 2B, this one mathematically, you write it as 2 sine of A, sorry, now this is B, cos of B, cos of B. Even if you have made something like sine of 2 theta, mathematically we shall write it as 2 sine of theta cos of theta. Now, whenever you are going to be working with solving, you are going to be working with things, whenever you'll find sine of something, you'll have to state your identity like this, and then you go forward. Now, this is what we call the first double angle formulae that we have derived. Members, are we on the same page? Are we on the same page? Any question for those who came on early? Okay. Okay, no questions. Perfect. Okay. Now we are going to continue to the second one. Yes, Genesis.
Good morning, sir.
Morning.
Teacher, my question is here, like here when we've written sine of A, cos of A plus sine of A, cos of A.
Yes.
Okay, I remember yesterday as if it was, okay, as if cos is supposed to be the first, then sine this side. Is it okay to be like that also?
Okay, Genesis, tell us what is 2 times 3?
6.
What is 3 times 2?
6.
So what is sine of A times cos of A?
Sine of A, cos of A.
Sine of A, cos of A. What about when
Yes.
you have cos of A times sine of A?
Cos of A, sine of A.
Now, are these two things the same or they are different?
They are the same.
They are the same. Okay. Hope you have understood.
Yes, teacher. Thank you so much.
Okay. So we are going to now continue. So whenever it is a multiplication, what matters is you must interchange the angles. That one is very important. That even if you start with the cos and here you bring in the sine, make sure that the angles are interchanged. That is what is very important. Okay, we are going to continue. We go to the next one. It's going to be cos of 2a. Now, when it comes to cos of 2a, we shall still write this as cos of a plus a. But now we bring in our idea of the compound angles. We know very well that from our compound angles, when I have cos of a plus b, we know it that this is cos of a, cos of b, minus, Genesis, what do you have? Sine of A, sine of B. We say that for the cos, the plus will match with a minus. Now, when you look at what we have, you note that all our angles are A's. So that means that also here, we shall substitute in the same. So we shall come here and say that now we have cos of A plus A will equal to where there is cos, you put cos of A. Then we have cos here where there is B, our angle is A, minus sine angle A and sine of angle A. Members in the chat, what is cos A cos A? Cos A times cos A, what do we get? Place your answer in the chat. Thank you, Anthony. Anthony has said we get cos squared of A minus sine squared of A. Members, this is an important identity for our double angle formulae. That whenever you find cos 2A going forward, we shall write it as cos squared A sine squared of A. Whenever you meet it somewhere, that's what you are going to write. However, when we have the cos, we can transform it into either sines or the cos. So from this general one, we can obtain other two. You know very well that from your trigonometry, you know that when you have sine squared A plus cos squared of A, this one is always equal to 1. Now, what can happen is that if I make my cos squared the subject of the formula here, we shall have cos squared theta equals to 1 minus sine squared of A. Now, from this general one, if where there is cos squared theta, I replace it with this, what shall we have? So I want to come and say now, my cos of 2A will equal to, where there is cos, we shall put this. We are going to have 1 minus sine squared A minus sine squared of A. Now, what are we going to have? Members in the chat quickly. What is minus sine squared theta? Minus sine. Here relate it that if you have minus x, what is minus x minus x? Minus x minus x. So that is important. So that this is the same as 1 minus 2x. Similarly, when we come to minus sine squared minus sine squared, we are going to get 1 minus 2 sine squared of A. Now, when you have cos of 2A, we can as well write it in this format. That is the second way. Then the other last way is, what about when you have sine squared of A plus cos squared of A equaling to 1? What about this time round? If you do not make the cos, you make sine. So when you make sine squared of A the subject, we shall end up with 1 minus cos squared of A. Now, in this where there is sine squared, we shall place this. So now I can come and say, I'll have cos of 2A will equal to cos squared of A minus 1 minus cos squared of A. So when I open the brackets, we shall have cos squared of A minus 1. Minus and a minus gives us a plus cos squared of A. Then you collect like terms. Cos squared A plus cos squared A is the same as 2 cos squared of A minus 1. Now, this is another double angle thing. So we can now write it. Now, when it comes to cos 2 of A, we can write it in any of these. This is the first one, this is the second, or the third. And it will always depend on the situation you are dealing with. So you may meet an equation that will require you to just go straight here. You may meet an equation that requires you here. You may meet an equation that requires you to apply like that. So this is very important. If you have any question, you may ask. Okay. Yes, Mike?
A very good morning to you, sir, and thank you for the good
Morning.
work done. I'm just requesting for a pardon on cos 2A is equals to cos into A plus A. And then the next step was cos into A plus A is equals to cos A, then times cos A. Just a pardon on only that.
Come again.
I was requesting just for a pardon on the next step, how the next step came about.
From where?
From the second step of cos into brackets A plus A equals to cos A times
How
cos
this
A
one
minus.
came about?
Yes.
Do you know compound formulas, the compound angles?
Yes, I know the compound angles, yes.
Expand for me this. A plus B. What do you get?
I get cos A, then times cos B, then minus sine A times sine B. Okay.
Hope now it is answered.
Yes. Thank you, sir.
Okay. All right. Okay. Members, are we good to continue? Okay. All right. So we are going to now continue. Yeah. Okay. Now we are going to look at the one for tan. Now, still, when it comes to our tan of 2A, Still, we are going to first write this as that I have my tan of A plus A. Now you go back, you remember from your compound angles that what is tan when I have two angles? That when I have two, this is the same as tan of A. We are on tan. Then plus, what do you have? This is tan of B out of 1 minus tan of A, tan of B. You need to remember that. You come back here. These identities, these are the identities we are utilizing. Now, after writing it, you relate that here your A is A. Your A is the B. So we are going to just go on. So we shall come here and say that tan of A plus A will equal to tan of A plus our tan of A out of, what shall we have? 1 minus tan of A, tan of A. So here, tan A plus tan A will give you a 2 tan of A out of 1 minus tan squared of A. So that is the formulae. Yeah. Now, those three things, members, we have looked at. The tan of 2A, the sine of 2A, and the cos of 2A are what we call the compound angle formulas. And whenever you meet them, you are, depending on the situation you are dealing with, we shall be expecting you now to be filling in this. To know that whenever I find cos 2A, this is what I put. Whenever I find sine of 2A, this is what I put. Whenever I find this is what I put. So that is how we get that formula. Okay. So let me give you time. When you finish, you let me know, and then we can continue. Hadia,
Yes, please.
are we on the same page?
Yes, we are.
Okay. Yes, Maggie?
Sir.
Yes.
So I was asking here on the third last method for sine for cos, we had sine squared A plus cos squared A is equal to 1.
Hmm.
And on the third step, the cos, I don't know where the sine disappeared because we had cos 2A is equal to cos squared A minus, into brackets, 1 minus cos squared A.
Now, where there is sine squared A is the same as 1 minus cos squared A. So we substituted in.
Okay, thank you.
Yeah. Okay. Okay. So we are now going to start. Okay. We are going to start the application. Now, they have told us that we have cos of x is equal to negative 3 out of 5, and that our angle of x is between 90 and 180. Find the exact values. Like I've been telling you, always learn to draw the quadrants. So I'm going to first make my sketch. After sketching, I'm going to ask, our x is 90. So I'll come here and say, this is 90 and this is 180. What does it mean? It means that our triangle, the right angle triangle, is going to be in this quadrant. So I'm going to come, I sketch. And like we said that always your angle, the reference angle, is measured with respect to the axis you have. Now, since they have given us cos, we are going to come and say that we have cos of 3 out of 5. But what is cos? Cos is always given by the adjacent out of the hypotenuse, meaning that this 3 is your adjacent. So here we shall have 3. Your hypotenuse is 5. So here we shall have 5. Now, are we supposed to have? We need to first obtain what is our opposite. What is this opposite? Members, can we calculate the opposite? Can you get the opposite? Members are getting the opposite as 4. The opposite is 4. So we are using the Pythagoras theorem. We are saying a squared plus b squared is equal to c squared. So this is 3 squared plus b squared is equal to 5 squared. And then you make your calculation that this is 25 minus 9, 16 is equal to b squared. Then you get the root. You get the root. So that's how members are getting the 4. So here we shall have the 4. Now we are going to start. Now we know when you look at part A, they have told us that obtain our part A. I'm going to work it from here. They want sine 2x. Now from your double angle, you know that sine of 2x is given by 2 sine of x cos of x. That is from what sine 2x is. Now, what are you going to do? You are going to substitute what is the sine. But you need to know the quadrants that here it is sine. That is positive. So we shall substitute 2 times what is sine. That sine is always given by the opposite out of the hypotenuse. So here we shall put 4 out of 5 times what is cos. Cos is given by adjacent out of the hypotenuse. So it's going to be 3 out of 5. But in this quadrant, we know that cos is negative. So I'll put here my negative. So we are going to continue and now multiply that we shall have 2 times 4 times negative 3, which is going to give us negative 24. Then everything out of 25. Because 5 times 5 is 25. And therefore, this is our sine of 2x. Let me hope you have understood that. We are applying the identities. Members, any question on that? Have we understood that? Okay. We are going to go to the second part, which is 4x. Now, when you are dealing with the 4x, still you are going to apply. But this one, allow me, I want to first show you. Now, when you are dealing with the 4x, I'm going to first show you and then we shall conclude. When you look at the 4x, members, you know that 4x, you can write it in double angles. Can you write for me in the chat? How can we write 4x in terms of double angles? When you are writing it in terms of two angles, like which 2 angles that you can have to get 4x? Place in the chat what you think. Someone has said 2 and 2. Yes. So that means 4x, members, you can write it as sine of 2x plus 2x. That's how you can write it. What does it mean? It means that when you go back to your expansion of sine of a plus b, you know that this is sine of a, cos of b, plus sine of b, cos of a. So when we substitute, we shall have sine of 2x, cos of 2x, plus sine of 2x, cos of 2x. So at the end of the day, what are you going to have? Sine 2x, cos of 2x, sine of 2x, cos of 2x. So you are noticing that this is going to be 2 sine of 2x, cos of 2x. Now, that means that if you have sine of 4x, this is the same thing as writing 2 sine of 2x, cos of 2x. Now, you look at the angle you have here and look at what you have. Members, have you understood that? Ask before we continue. Ask. Have you understood that part now? Okay, I need to first answer some questions because you need to understand. I don't want you to cram. Yes, Jeremy. You may ask.
Excuse me, sir.
Yes.
I thought it is 2 sine 2x plus 2 cos 2x.
Where?
On the second step.
Hope you know that this is the same thing with this, right?
Yes, sir.
Yes.
Oh, I've realized.
Okay.
Yes,
ZTE.
sir.
I was also having the same question.
Oh, okay. Is it clear now?
Yes.
Okay. Galax.
Just what I wanted. I got some confusion there where you got sine 2x cos 2x.
It is here. Are you seeing this identity? Your
Yeah,
A is 2x. Your B is 2x. So you substitute here 2x, substitute here 2x. Substitute here 2x, substitute here 2x.
okay, I get you, I get you.
Okay. Trudy? Okay. Now, we are going to continue. So, what are you going to notice? But members, now this is for sine of 4x. Now, members, I have one here. You tell me in the chat, I want us now to generalize. I want us to just be generalizing. You to tell me something like this. If I have 6x, what shall we have this side? Put it in the chat. If you have 6x, what shall we put in the chat? I want you to put for me an expansion like of this nature. That's what I want. Thank you, Mark. Thank you, Julius. Perfect. Perfect. Now, remember you must have sine and cos only. So you need to look at. Let me put for you one more. Let me put for you one more. I have, what about when I have 8x? What shall we have this side? What about when I have 8x? What shall we have the other side? Thank you, Julius. Thank you, Mark. Joviat. Yes. Yes. Now, members are understanding. Very good. Okay. Matthew. Yes. 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 Now, that is what now you need to know. That if you find, and you are going to find out that the angles here, there is something you do. What about members? What if we had sine of 10x? What if it was 10x? Yes. I don't know whether someone has now been able to crack the code. But here, remember, these are double angles. So that means that we do not look out for odd numbers. So you cannot say sine of 9x because you may not be able to get those two digits. Yeah. Yes, much as it can be expanded, but you may not be able to get because the angles are going to be different. Okay, very good. So let me hope members now are identifying, are able to see the pattern. You must be able to see the pattern. The last one to test, what about in case we had sine of 20x? What if we had sine of 20x? You must be able now to see the pattern. What about if you had sine? Thank you. Thank you, K. Mark. Yes, I've seen the answer. Julius, taking note, Matthew. Yes. Now, that is very, very important whenever it comes to identities, because time is going to come when you are going to just be quoting them. Yes, Hadia, that's okay. Gabjela and Shadia. Yes. Okay. Reste, yes. So now you are going to allow me to clear my screen and I'm going to just quote. Yeah, I'm going to just quote. Now for part B, members, I'm going to just quote since now we have seen how things come about. So here I'm going to come and say for part B, where we have sine of 4x, I will just say that this is the same as 2 sine of 2x cos of 2x. Now the beauty is we have obtained sine of 2x, but I don't have cos of 2x, so I'm going to first obtain what is cos of 2x. Now we know that cos of 2x from our identities, you can use 2. You know that it is the same thing. When you go back to the identities we developed, you say that cos of 2 of an angle is the same as cos squared a sine squared of a. That is okay. So you can use any of these ones. So I am going to use one of them, but for you it is okay to use any of your choice. So I'm going to say that this is the same as cos squared a minus sine squared of a. But what is cos of a? Now I'll come. But now since this is x, this is going to be cos x. Sorry, this is x. But what is cos of x? I'll come here that cos is given by adjacent out of hypotenuse. But since we are in the negative, it will be negative 3 out of 5 squared. Minus, what about the sine? That the sine is given by my opposite out of the hypotenuse. So it's going to be the 4 out of the 5, everything squared. So when you square, we shall have here 9 out of 25 minus 16 out of the 25. So we shall end up having our 9 minus 16, which is negative 7 out of 25. But even if you did not want to use that, you could come and say that now cos of 2x is the same thing like 1 minus 2 sine squared of x. So still you can use this and say this is 1 minus 2. What is sine? Sine is 4 out of 5, everything squared. So this is 1 minus 2 times 4 squared, which is 16 out of the 25. So this can be 2 times 16, which is 32. So it is 1 minus 32 out of 25. And when you get 1 minus 32 out of 25, you end up with the same answer as negative 7 out of 25. Even if you had used that 2 cos squared of x minus 1, still you'd have obtained the same what? The same answer. So whatever thing you use, you'll get the same what? The same answer. Always make a choice on which one is easy and which one you want to utilize. Okay, now after obtaining the cos of 2x, we are going to come back here and we fill in. So we shall now come and say that our sine of 4x is equal to 2 times sine of 2x, which we had already obtained as negative 24 out of 25, times cos of 2x, which we had obtained cos of 2x as negative 7 out of 25. So you do your mathematics now. Negative times negative is a positive. Then 2 times 24 times 7, which gives us 336 divided by 25. 25 times 25, which is 625. And this is your sine for the 4x. In case it can be reduced, then you can go on and reduce. In case it can't, then you leave it at that point. Can I know whether we're on the same page? Are we on the same page on that? Ask in case there is anything you are not understanding. We shouldn't leave you behind. Okay, let me pick this hand. Yes, Baby Angel.
Good morning, Master.
Morning.
Master, I'm requesting for your pardon.
Where?
From here, of sine 4x equals to sine 2x plus.
Are you saying now, Angel, we are substituting that here,
Yes.
sine of 2x here, since we got it in part A, it was this. So where there is sine 2x, that's what you put. Then cos of 2x is what we have calculated here. So we put this. So that's what we are putting.
Okay, Master, thank you.
Okay. Otwanch, Otwan?
Sir, for me, what I was asking is they have told us cos x equals to -3/5. So
Yes.
when we are making it, I thought it's supposed to be, even when we're having adjacent over hypotenuse, I thought it's supposed to be -3/5, like indicate the -3 as adjacent in our triangle.
No, the negative, the negative that you put there, the negative shows you the quadrant. That negative means the quadrant, that within that quadrant, the thing you are dealing with is negative. That cos is negative. But there's no need for you to put it there on your diagram. Hope you have understood.
Oh, and also, so if you had a bigger range, because so we would have had also another triangle in the tan quadrant if we had a bigger range.
Aha, yes. If it was 360, then we'd also have come here. Are you seeing here? And then we draw another one. But now it cannot be here. It would have been here because we know that here, this is where cos is negative. So we would have had another one here.
Oh, okay, sir. Thank you.
Okay. Okay. Lastly, Angel. Hope members have finished, right?
Master, I was
Yes.
asking how did this second step come about?
Which step?
This one of cos 2x.
Cos of?
Cos of 2x equals to cos squared x minus sin squared x.
No, this is an identity. Hope you have not just joined.
Yeah, I've remembered.
Hey, how we expanded, right?
Okay, Master.
Okay. 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 We are now going to proceed to the next one. Aha. Now, we have tan of 2x. Why don't you do that one also? May I come on the last one? Hey, remember what your tan 2x is equal to. So remember from our identities that this is the same as 2 tan of x out of 1 minus tan squared of x. So that means that where you come here on your diagram, get what is tan of x. That tan x is given by my opposite out of the adjacent. But you remember what happens, that in this quadrant, tan is negative. So you'll put here a negative. Then you substitute that this is 2 times -4 out of 3, everything out of 1 minus -4 out of 3 squared. So can you go on and get the answer, members? And then you place for us your answer in the chat. Get the answer, get the answer. Okay, have we got some answer? Yes, Chisachi, any identity can work. Hey, don't write decimals here. Your accuracy is very clean. Okay, people are getting 24 out of 7. 24 out of 7. 24 out of 7. That is very correct. So, 24 out of 7. Thank you, members. That is correct. Okay, 24 out of 7. 24 out of 7. Yeah. Okay. Are we good to continue now? Are we good to continue? Okay, someone has said, yeah, we are good. We are good. Yeah. Now, the next one we are going to do. is the one that requires, let me, allow me to, Genesis, you may ask, and Pixel.
Teacher, I'm requesting to help me go through like how they are getting 24 out of 7.
Okay, Genesis, first tell us. Genesis, first tell us. What do you have in the numerator? When you work
And then
out. Yeah. Here, what did you get for the numerator? This.
up, oh, I got -8, like out of 3.
Everything divided by 1 minus. What do you have here in the root?
Let me put it there. -4 divided by 3. When I put this in the calculator, it gives me 0.36.
You get it in decimal. Now you place a B/C. Place that one to give it in fraction. Because the moment you put decimals, you are going to get something that's not accurate. So what do you have?
Okay, that's great.
Place that button for the fraction.
Sir, a moment, please.
But here you could just square Genesis. You could just
Yes,
square
teacher.
now that this is -4 out of 3 times -4 out of 3. So -4 times -4 is 16. Out of 3
16,
times 3, which is 9.
9.
Then this would be -8 out of 3. Then you get in your calc 1 minus 16 out of 9. 1 minus 16 out of 9.
1 minus 16 out of 9. It's -7 out of 9.
Negative?
7 out of 9.
So then after you divide, you say -8 out of 3, divide by -7 out of 9. Then you say this is -8 out of 3 times 9 out of -7. The negative cancels, then you remain with that.
Okay,
This,
thank you, teacher.
okay, 72 out of 3 times 7, which is 21. Then you can reduce.
I've understood, sir. Thank you so much.
Okay. So now members, let's start on the tan. Now, when we go back to what we are going to be finding out is tan over half of x. So allow me to write that we have our tan of a half of x. Now, what do you do? What are we going to do? You need to quickly think, how can I generate tan over half of x? That is one thing you need to think about. You need to think that if I'm to get tan over half of x, where can it come from? Now, I want to bring it to your attention that members, if I have tan of x, how can I write tan of x in terms of two angles? Quickly think and place your answer in the chat. I want to write tan of x in this form of tan of a plus b. So what do you think is going to be our a and what do you think is going to be our b? Ah, I have used Narak. I'm using addition. Yes. Members have got that. So members, you note that when I have tan of x, this is the same thing as having tan of x out of 2 plus x out of 2. That is very important. But you know very well from our expansion that when I have tan of A plus B, this is the same thing as tan of A here, tan of A plus tan of B out of 1 minus tan of A, tan of B. You know that. But also from our angles that we have looked on, we have said that now like I'm going to substitute, I have x out of 2, x out of 2. So since I have tan of x out of 2 plus x out of 2, I can write this as tan of x out of 2 plus tan of x out of 2 out of 1 minus tan of x out of 2 tan of x out of 2, which you can conclude tan x out of 2 out of the other one is 2 tan of x out of 2. Divide by 1 minus tan squared x out of 2. And I want you to take note that this is the double angle thing that we had. Now from here, you know that tan x out of this is the same thing as tan of x. Can you first digest that and let me know through the chat whether you have understood up to that point? Yes, Jeremy?
Good
Okay.
morning, sir.
Yes, morning.
Excuse me, sir. I was saying that how do you get x when you expand x over 2 plus x over 2? Like,
Okay,
it's just like
Jeremy, what is a half plus a half?
a quarter. No, okay.
Add well.
Define that.
What is a half plus a half?
It is 1.
It is 1. So x out of 2 plus x out of 2 is the same thing as x. Is the same thing as the wall.
Yes, sir. Thank you,
Hope
sir.
it is. Okay. Emma?
Okay.
Sir, I'm like, on that last step, why haven't you placed the squared on x out of 2?
Oh, no, these are angles. We don't multiply angles. We multiply the tans.
Oh,
Yeah.
okay, thank you.
Okay. The angle remains the same. Okay. I think from the chat, I think we are getting there. Now, what are we going to do? Now, we are going to continue working out. Now, we know that from our triangle, we have tan of x now equals to 2 of tan of x out of 2 divided by 1 minus tan squared x out of 2. Now, when you look at our triangle that we had, our triangle was like this, where we had our value of x, just to be sure, 3, 4, 5. This was 3, this was 4, and this was 5. Now, we are going to ask ourselves, what is tan of x? So I'm going to come and say that tan of x is given by opposite out of our adjacent. But what is our opposite? Our opposite is 4. What is the adjacent is 3. But what do we need? You need to know that in this quadrant, what is the sign of tan? That in this quadrant, tan is negative. So we shall put here that it is negative. Now, after doing so, we are going to substitute. Where there is tan of x, we shall put negative 4 out of 3. So we are going to come here and say negative 4 out of 3 is equal to 2 tan of x out of 2, everything divided by 1 minus tan squared x out of 2. Now, the moment we reach here, we are going to solve this equation. How are we going to solve? We are going now to cross multiply. We cross multiply, cross multiply. So once I cross multiply, I'm going to have my negative 4 into 1 minus tan squared of x out of 2 equaling to 3 times 2 tan of x out of 2. So let me hope we are on the same page, everyone. Are we on the same page at that point? Are we on the same page? You may ask that this point I've not yet gotten where. That is very important. Which point are you confused? Which point is not clear? Raise up your hand for those who are not there. Yes, ZTE?
Excuse me, sir.
Yes.
Why haven't we substituted this x out of 2? That is on 2 tan, this one 2 tan x out of 2.
Now, when you look at the angle you have here, this is a full angle. But this angle you
Yes.
have here is a half an angle. So we don't know its trigonometric ratios.
Okay. Thank you,
So
sir.
this is half an angle, but here on our diagram, we have a full angle. So we don't know what is the half an angle equivalent to.
Okay.
Okay. Poleman?
You said it's half an angle,
Yes.
but we got the angle. Why don't we get the half of that angle?
We have not gotten an angle. We have only gotten its ratio. That is just the ratio of a full angle, but we don't know what the size of an angle is.
Okay, sir.
Okay. Then Jeremy?
Excuse me, sir.
Yes.
I thought when you multiply the 3, which is a denominator, by the 2 tan x over 2, it multiplies everything in the what? In the tan. It multiplies everything in the... It multiplies 2 tan x.
Jeremy, this is an angle. An angle cannot be affected by an external factor. An angle is always intact.
Yes, sir.
So like when you say 2 times sine of 2 theta, you'll not be able to say that this is the same as sine of 4 theta. No, this is not okay. This 2 only affects the coefficient that is being carried by the sine.
Yes, sir.
Okay. Okay, so when we open up the brackets here, we shall have negative 4 plus our 4 here, tan squared of x out of 2 is equal to 6 tan of x out of 2. Now we are going to write this in a good quadratic way. Because this is a quadratic equation, we are going to take all the terms the other side. So I'm going to start with 4 tan squared of x out of 2. Bring the 6, we have 6 tan of x out of 2 minus 4 is equal to 0. So you're going to allow me to write it on the next slide as 4 tan squared x out of 2. I think to be sure, is it minus? Yes, minus 6 tan of x out of 2. Then there was another value of negative 4 is equal to 0. So in case you have a question, we must be moving on the same page. Okay. Okay, let me pick only one. Yes, Otwanj? Okay, I failed to get Otwanj. Okay.
Yes, sir.
Now,
Sir, what I was saying, hello, you?
yes, continue.
What I was saying, like, we are here. Why can't you, on a good day, can't you just, since we know that tan x squared is, there are 2 tans, can't we just cross out this tan and remain with 1 tan x?
Which tan?
Like, it is tan squared. That means tan x was multiplied twice. So can't we remove this one, this side, and we cross out this one on the 6 and remain with 1 tan?
Okay. Now, can I ask also?
Yes.
Otwanj, can you
Yes.
cross 2 and this one?
No?
No. Why?
Because you can't.
So have you got the answer now?
Yes.
You have got the answer.
But sir, this one is equals.
Where is the equals?
Like this tan x.
Here, you are saying this step?
Yes.
Also, I'm going to give you. What is your answer there?
5 equals to 8.
Okay. Now let me put here an x squared and I put here x. How do you deal with that, Otwanj?
Quadratic.
Hey, do you just cancel the x like this?
No.
Okay. Hope it is okay now.
Yes.
Okay. So now when we reach at this point, this is a quadratic equation. Now you have two choices. Either you let your tan x out of 2 equals to a letter, or you work it the way it is. Put in the chat, let or work it out the way it is. Ara said let. Okay, so we are going to let. So we are going to say that let our tan of x out of 2 equals to m. So now we shall have 4m squared minus 6m minus 4 equals to 0. Now you are going to ask yourself, I'm going to use factorization. So you ask yourself, what is the sum? Sum is -6. What is the product? Product is 4 times -4, which is -16. Now you're going to look out for 2 digits. You multiply, you get -16. You add, you get -6. Which digits are those members? 8 and 2. 8 and 2. Hope everyone is getting those. -8 and 2. Yes. So when you have -8 and what? And 2, when you multiply, you get -16. -8 plus 2 will give you the -6. Yes, Rins? Okay. So we are going to come back and say now 4m squared. Where there is -6m, we shall replace with our 2 digits. So we shall place -8m plus 2m minus 4 is equal to 0. So I'm seeing some hands, but they are not. Klepton and Maggie?
So
Thank you, sir.
Yes?
Sorry for taking us back. I came a little bit late, but I wanted to just understand one part. When you go back to the start of this question, how did tan half x turn to tan x out of 2 plus x out of 2? That's something I want to understand from there.
No,
Thank
like
you.
I explained that what is a half plus a half?
1.
1. So what is x out of 2 plus x out of 2?
X.
Yeah. So this is what we are looking for. But when you look at the question had x out of 2. So we need
Yes.
to be creative to ask ourselves, how can we generate x out of 2?
Yes.
So that's what we are doing. We have not reached the answer.
Okay.
Yeah.
Thank you.
Okay. Maggie?
So I was trying to ask where the product was because I'm seeing 4 times -4.
Yes.
And
Product mass is A times C. This is your A and this is your C. That's
okay.
how we get a product.
And master, I was trying to say, can't we reduce it at first? Because I can see it is divisible by 2.
It is okay. Whatever thing you decide, it is well.
Okay, thank you.
Okay. So here, members, we are going to come here. We shall come here. So here, when you factor out, you'll have your 4m into m minus 2. Then plus, here you'll have your 2 into m minus 2 is equal to 0. Meaning that you have 4m plus 2 and you'll have m minus 2 is equal to 0. So that means that either you are going to have 4m plus 2 is equal to 0, 4m plus 2 is equal to 0. Sorry, 4m is equal to negative 2. And there you'll have your m is equal to negative a half. Or you are going to have m minus 2 is equal to 0 and m is equal to 2. Now, after obtaining those two values, you come back here and you say that now, what do I have? I have tan x out of 2 is equal to m, which is 2. Then I have my tan of x out of 2 is equal to negative a half. Now, you bring in the idea of quadrants. You ask yourself again, when I look at this quadrant I'm dealing with, I have this, I have this. In which quadrants of my tan is it positive and is it negative? Looking at the range you have, which range am I going to look at? So now you start what? Reasoning out. So I'm going to ask you now to think about when you look, because remember at the end of the day, we want tan of x out of 2. Yes. So I'm allowing you to think. I'm going to allow you to think. But now I'm bringing it more to your attention. Here you have to listen and it is understanding. When you look at our domain here, was given as 90 to 180. So I'm going to come here. That the domain for the x was given as 90 degrees less than x less than 180 degrees. But since you have x out of 2, what does it mean? It means that if you are to get x out of 2, this domain here must reduce. So in other words, if our domain is to have x out of 2, then members, tell me, what are we going to have here and what are we going to have there? Put for me in the chat. What will our domain equal to? Put for me in the chat. Are members now tapping? That here now it's going to be 45 degrees. And this side you are going to have 90 degrees. Perfect. Now, after obtaining that this is going to be 45 and 90 degrees, you are going to ask yourself that I have two answers. I have the 2 and I have the negative a half. Now, when you look at the quadrant which has 45 and 90, which quadrant is that? That this is 0, this is 90. Now, if you are to look in this quadrant, which quadrant will our x out of 2 be? Which quadrant is that? It's going to be in the first quadrant. Now, if it is in the first quadrant, when you look at tan of this and this, which answer gives you that quadrant? Which answer gives you that quadrant where tan is positive in the first quadrant? That tan, the answer is 2. So that means that we are going to eliminate this answer because this one shows us that tan is x out of 2 is negative, of which this one is not in the first quadrant. Tan can't be negative in the first what? Quadrant. And therefore you are going to conclude that now your tan of x out of 2 is the same as 2. And this is your answer for your domain 45 degrees less than x out of 2 less than 90 degrees. Hope you have understood that. It required a lot of understanding. You may ask, why does the domain reduce? Because the angle was reduced. The angle was halved. So when you halve the angle, the domain can't remain the same. The domain has to adjust. Aren't we getting the angle? No. Because what did the question ask? When you go back to the question wanted you to find what is tan of x out of 2. What is that exact value? They never asked that what is the value of x. Okay. Now I'm responding to questions. You may put them in the chat. You can raise up your hand. Okay. Yes, Maggie.
So I was trying to ask, On the first part for sine 2x, it don't it,
Come again.
it,
Okay, I'm not getting you, Maggie. You can type. Poloman.
Teacher, as you answer questions, I'm requesting you display the question, the scenario.
Okay, I'm going to do so. SC.
Teacher.
Yes.
Good morning. Good morning, teacher.
Morning.
Teacher, like the other this part, okay. Where I've used the product under sum, yeah. Can you use the bulldozer method and obtain the same
Yes.
materials?
You get the same.
Okay, teacher.
Even you can use completing squares. Use any approach of your choice. You'll get the same answer. Yes, Shali?
Sir, I think I had the same concern with her.
Oh, okay. Yes,
Teacher,
Genesis?
my question is, what was really the purpose of dividing 90 and also 180?
Is you want to obtain the domain for this. That this is half an angle and this was a full angle. So to get half an angle, you divide through by 2, by 2, by 2, such that you know the domain for this. Now, the domain for this angle is the one that informs you which answer to take. Because here, you note that this is positive, this is negative. But now, which which one are you going to take? Are all of them correct? The answer is no. But now when you look at this domain specifies for you that x out of 2, when you have the angle, it's going to be between 45 and 90. And you know that in this quadrant where we have 45 to 90 is in the first quadrant. What does it mean? It means that tan in that quadrant is positive. So that's why now we go with this answer. Because this is a positive ratio. But if our domain was different, let me say you had, let me say 270 to 360. And then you have the angle. You'll notice that your domain now will be in another what? Another quadrant. So that's what you base on.
Okay, teacher. Thank you so much.
Okay. Lastly, Mercy. Okay. So we are going to continue. Yes. We did not use negative a half because this between 45 to 90, our tan has never been a negative. Our tan is always positive. What if they wanted the value of x? Would you then get the one of x out of 2? Yes. Now, up here, you first, in case they wanted the value of x, you'd have first obtained x out of 2, and then you continue. But even if they wanted the value of x, you could just use the one of tan x because you had already obtained the tan of x. Yeah. If they ask hence solve for x, then you will just come here, get x out of 2, get tan inverse of 2, obtain all the angles that give you tan inverse of 2, then multiply the answer by 2. Now for this case, when you check out tan inverse of 2, the answer is going to be 63. Then you multiply. Yeah. No, because we had never met such scenarios. Because we had never met such numbers. So that's why the domain has to change. Okay, so we are going to continue. The rest you can place your answers in the chat. Here we have adjusted the domain. Remember, I want you to understand, we have adjusted the domain such that we can make a conclusion on what values on which one we are to take. Which one to take. Yes, that one you need to be very careful. That's why when you get tan inverse of 2, the answer you are going to get is going to be between 45 and 90. For you try to get tan inverse of 2, the answer you get is going to be between 63. And now even for this case, in case they wanted you to get angles of between 6 and out, your answer would just be 63.4 degrees and you stop there. In case they wanted you to get just x out of 2, you'd have stopped there. Yeah. Okay. So we are going to continue. So I'm going to ask you to first look at this number. We are now applying. Okay. Now, we have been given that solve the equation. Now, still when we come to solving, you have 2 sine of 2 theta is equal to cos of theta. Now, you can never solve this number the way it is. But what do you do? Here, you apply the identities. That if I have sine 2 theta, what is that equal to? That sine 2 theta alone is the same as 2 sine theta cos of theta is equal to cos of theta. That is the first thing. Then now you can open and have 4 sine of theta cos of theta is equal to cos of theta. Now what are you going to do? You are going to collect the like terms. So that means you'll have 4 sine theta cos of theta minus cos of theta is equal to 0. But you notice that cos and cos are common, so you can factor it out and say cos theta into 4 sine of theta minus 1 is equaling to 0. Now, the moment you reach here, then you are going to say that either I have my cos of theta equaling to 0, or this side I'm going to have my 4 sine of theta equal minus 1 equaling to 0. Now, here, you note that you bring in the idea of the quadrants, that cos is positive. So I will come here, I draw my quadrants. Then I get my reference angle, that cos inverse of 0 is what? You place your calc. That what is cos inverse of 0? That it is equal to 90. Meaning that when you place, this is 0, this is 90. So you notice that your reference line is going to be along this axis here. That is where your reference line is going to be. So when you try to move the first time, you'll get 90. When you try when you try to move in another quadrant where cos is 0, you notice that all. So when you try to move from this axis here and you are trying to obtain your cos, you notice that you are going to move from here up to here. So that means that the second reference line is along this axis. Then you still move up to when you reach there. So you notice that the angle you are going to land on is going to be that angle. What angle is that, members? Put it in the chat. What angle is that? 270. Good. So that means that you are going to have the two angles, 90 degrees and then the 270 degrees. Those are the two angles you are going to have for that case. Then you come this side. You say now, I have 4 sine of theta will equal to 1, meaning that sine of theta will equal to 1 out of 4. Then get the reference angle, that my ratio is positive. In which quadrant is sine positive? In the first and the second. So get your reference angle first, which is a quarter, sine inverse of a quarter. Then when you get the sine inverse of a quarter, you end up with your answer as 14.48 degrees. Now you know that your angle is going to be here, 14.48. Your angle is going to be here, which is 14.48. Can you get all the angles? Get the angles. Let me give you a minute. Get all the angles as I'm going to be responding to some items. get all the angles. I'm seeing a hand from Daniela. Daniela? Okay, I failed to get Daniela. Henry? I'm failing to.
So I got the other angles. The other one is
Okay.
14.48. Then the other one is
Uh-huh.
165.
100?
165.52.
52 degrees. Okay, thank you. And
And
when
then
you
my
look at,
question,
yes,
I have a
come.
question. Last
Yes.
time you told us, last time you told us, as long as we have sine theta or cos theta or anything like tan theta, we know that that theta is in radians. So I'm still asking,
Oh,
are those
now,
angles in radians?
are you seeing this? Are you seeing this?
Yes.
So, which units are these?
Those are degrees.
So they have indicated for you that theta is in degrees. So your calc must be in degrees.
Okay.
Yeah.
So if the domain was in pi something, what was the? I would know that it is in.
Yes. If it was in pi, then you work out everything in radians.
Okay.
Okay. Henry? Okay. Samsung?
That was it.
Okay, that was it.
Teacher.
Ask. Okay. Kama?
Yeah,
Teacher.
I've got a problem. How to get the angles from the quadrant? I've failed.
Is this your first lesson, Kama?
Yes.
Oh, then that's where the problem is. So, Kama, I'm going to refer you. You are going to check out the previous lessons we have had because we looked at how to get the angles from the what? From the quadrants, because you need to know how to obtain the reference angle. Then after getting the reference angle, you need to know how to position.
Okay.
Yes, so I'll ask you that kindly go and visit those previous videos because I know the lesson was about 1 hour, such that you can learn from the foundation how to get those angles, how to obtain the basic angle. The basic angle is the first angle you obtain, that is an acute angle. After obtaining that angle, always look out for the quadrant where that angle lies, and then after you start measuring.
Okay.
Okay, so after we say that, always after calculating your angles, make a conclusion and arrange them in the right order. So we shall start with this one, followed by 90 degrees, followed by 165.4 degrees, and then followed by 270 degrees. So, and always look at this domain they have given you, that it is 360, meaning that we shall go and stop at 360 degrees. Okay.
Teacher.
Yes.
What I'm asking, how did you hear after 4 sine theta cos minus cos theta is equal to 0, and then down it was cos theta in brackets sine 4 sine theta minus 1. How did you reach that part?
Are you saying cos is common? Cos is common here. So I factored it out. Because there was cos and there was cos. So when you factor it out, here you remain with 4 sine theta. Here you just remain with the 1, which is this.
Oh. Thank you, teacher.
Okay. So members, we are going to continue now to one more. Now, still using the knowledge, using the knowledge of this double angle, they can also ask you to show something. They may ask you also to prove that something. Now, there are other identities earlier on that we did not look at. There are some proofs we did not look at because we had not learned, but they can also ask you to utilize them. Now, when you meet such, you need to know now that I'm going to apply the knowledge that I do have. So we are going to show this, that is very true. So we have 2 theta plus our sine of theta divided by cos of 2 theta plus cos of theta, then plus our 1. And they want us to show that what you have on your left is equal to what you have on your right. Now, what do you have always to do? Now, always you need to know your knowledge of the angles. Now, when you look at sine 2 theta, this is a double angle. So we know how to expand that is 2 sine of theta cos of theta, then plus our sine of theta, divide by. Now you know that cos of 2 theta is given by that. Now you need to quickly think that if I'm to eliminate things to remain with the tan, it means that whatever thing I'm going to have down must equal to sine. Sorry, it must be cos. Whatever thing I have up must be in terms of the sine. So what are you going to do? You notice that you have cos of 2 theta, but we have looked at an identity that cos of 2 theta is the same as 2 cos squared theta minus 1. Now, where there is cos of 2 theta, we are going to replace with this. So we shall come here and say that this is now the same as 2 cos squared theta. Sorry, this is minus 2 cos squared theta minus 1 plus cos of theta plus the 1. Now, what are you going to remain with? You notice that in our denominator, this is negative 1 and this is 1, which ends up as a 0. So that means I'm going to remain with 2 sine of theta cos of theta plus sine of theta, divide everything by 2 cos squared theta plus cos of theta. Now you are going to collect, like you are going to factorize. When you look in the numerator, you notice you have sine theta, cos theta, sine theta. So meaning that sine theta is common. So when I factor it out, I remain with 2 cos of theta, then plus a 1. When you look at the denominator, you notice that cos is common. So when I factor out cos theta, I remain with 2 cos of theta, then plus the 1. And this one, you notice that these two can easily cancel. And therefore, once they cancel, you are going to remain with your sine of theta out of cos of theta, which will give you the tan of theta. So that's how you do, or you show that something is equal to that. But you use now the identities. That's now here. This is how you can use your knowledge of compound angles to prove something. Yes, Daniela.
Teacher, good morning.
Morning.
Teacher, I was inquiring how the one came about
Which
after
one?
getting here on sine theta into cos theta plus 1.
Here.
No, here.
Here.
No.
Oh, here.
Here. Like when you're almost concluding.
Here.
Yeah.
Hey, like here, you notice that when you look at this and this, you notice sine is here and sine is here. So sine is a common factor. It's like having, like when you have this, let me say 2x plus x, something like that. Or let me put here squared. You notice that the common factor here is x. So when you factor out x, you remain with 2x plus 1.
Okay. Thank you, teacher.
Okay. Otwaj?
So, Sam, for me, my question was, because from the previous thing, we have seen that cos 2a equals to cos squared a minus sine 2a. So why are we saying cos 2a minus 1?
No, like I've said, the identities are many. So this is an indicator that you did not come on time. Because we say that you know very well from your first identity that sine squared is the same as 1 minus cos squared a. This is where it comes from.
Yes, sir.
Yeah. Yes, Krypton?
Thank you, sir. Although my question is going to take us back a little bit behind, on the other part of the half angle of tan x out of 2. I just wanted to know, how would we react when we have the domain being a negative from like
The domain. Now, in
the
case the
domain,
domain,
like we have
let me
tan
say
x, if we have
270 less
yes,
than x less than
yes,
maybe 180, something like
yes,
this.
and we have
Then,
both of these.
and if
We
it
have
is
the
a
2 and the
half,
negative half.
you'd have made it a half. Then you
Yes.
say negative 270 divided by 2 is negative 135. Then less than, this is 180. 180 divided by 2, which is 90. Now you come to the answers you have got. Now you notice that here our domain has angles between negative 135 and 90. Now if this is true, you come back to your what? This thing, you know that
Yes.
this is 0 for negatives. This is negative 90. This is negative 180. Now, negative 135 is where? Is in this quadrant here. Are you seeing?
Yes.
Then where is the 90? Okay, I'm looking at negative 135 first. Now, negative 135, you notice that it is in this quadrant. But you ask yourself that all students take this. You ask yourself, in this quadrant, is tan negative?
It's positive.
It is positive. That means that now you can't take on this. Because this one
Yes.
shows you that tan is what? Negative.
Yes.
Yes. So that's how you can now act on such.
Okay. Thank you.
Yeah. But if it was, let me say, negative 180, and here now you get negative 90, it is between negative 90 and what? And 90. Still now you say that this is negative what? 90.
90.
Then you ask yourself, in this quadrant between negative 90, now, in case it is negative, let me even first put, in case let me say it is negative 180, okay, negative, let me say 9, negative 180, less than, okay, I want something like, let me say x less than, okay, less negative 180. Let me say this side is maybe negative 90, something like that. So that means that when you divide the half, this would be negative 90 less than x less than negative what? 45. When you divide by 2. Now, for such a case, you come that this is 0, this is negative 90. So the angle should be between negative 90 and negative 45. So you come, which quadrant is that? That this is the quadrant. Then you ask yourself, in this quadrant here, is my tan negative? What is the sign of the tan? That tan is negative here. So that means that this is the one you take. Because tan in that quadrant is not what? Positive. So that's how you can deal with that.
All right. Thank you very much.
Okay. So I think we are good to go. Marvin, is it a question? And ZTE?
Yeah, Master, it's a question.
Yes.
I was asking that where we have the cos 2 theta, what if we as 2 sin squared theta?
It is okay for you, whatever thing you use. You will notice that there is you are not going ahead. Yeah? Because if you use now here, like you said that let me use 1 minus 2 sine squared theta plus cos theta plus 1. Are you saying that? Then up, you'd have remained with the 2 sine theta, cos of theta, then plus sine of theta. You are saying that? Now, 1 plus 1, what do you get?
2.
You get 2. Now, you notice that 2 sine of theta, cos of theta, plus this is going to be sine of theta. Everything out of 2 minus 2 sine squared theta plus cos of theta. Now, when you reach here, you notice that things are not working out. So you ask yourself, how can I write sine squared in terms of cos? Then you say this is 2 sine of theta, cos of theta, then plus sine of theta. Now, where you have sine squared, you can write it as 2 minus 2 into 1 minus cos squared of theta plus cos of theta. Now you continue. Up you still have 2 sine of theta, cos of theta, then plus sine of theta out of 2. When you open the brackets, you have 2 minus 2 plus 2 cos of squared theta plus cos of theta. Now 2 minus 2 is 0. So that means that up you are going to make the 2 sine theta cos of theta plus sine of theta out of 2 cos squared theta plus cos of theta. Then you know that the common factor here up is going to be sine theta. So you factor the sine theta, you get 2 cos of theta plus 1. Then do the same down, that cos theta is common. So when you factor it out, you get 2 cos of theta plus 1. Then these ones cancel. So you get the tan.
Okay, teacher, thank you.
Okay. ZTE?
Excuse me, sir.
Yes.
Me, the problem is interpreting these signs of greater than and less than in the domain. Are we interpreting them starting with X, or we just read the whole thing?
No, with the X, the angle determines.
Okay.
Yes, the angle determines. Because the way you interpret the domain of tan of X is not the same way you interpret the domain of 2 what? 2X. Even if here they had given you a domain, let me say they had given you 90 less than X less than maybe 180. For X here, you take it the way it is. But in case here the domain is 2X, then here you can change and say that since the domain is multiplied by 2, I can multiply this by 180, I multiply this also by 2. Hope that is okay.
Yes, teacher. What about reading as in 90 less than X? Teacher, interpreting this, it means that X is less than 90 and
Now, when it is like this, it means that
that,
your angles, this is the
yes.
90, this is 180. It means that your angles you get should strictly be between 90 and 180. You shouldn't get any answer above that.
Okay.
Yeah.
Thank you, sir.
Okay. Lastly, Pixel, as members read through.
Excuse me, sir.
Yes.
I'm inquiring about this part of opening the bracket where you are like 2 into bracket 2 sine of theta cos theta. Then you got the answer as 4 sine theta cos theta. Why didn't you also multiply that 2 times the cos of theta?
Come again. Which part?
There was some certain example where you are like, yes,
Here.
this part of 2, the first one, the first step, like the second one.
This one.
Yes.
Okay.
When you're
You tell me.
expanding.
You tell me. You are there?
Yes, I'm there.
Which answer do you get here?
8x.
8x. Why? Why don't you have 8 times 2x?
It's not possible.
Not possible. Now, have you understood why?
Yeah. Thank you, sir.
Okay. Okay. So you read through this. Okay. Hope you have read. Okay. Now, when you look at this, whenever they are positioning devices, the angle at which these devices are tilted matters a lot. You have been seeing sometimes those who have, let me say, uh, dishes for Wi-Fi, that, or even these things of antennas and the rest of that, even these things, I don't know how they call these things for TV, those things they use, you have noticed that sometimes you have to rotate it in a given direction for you to be able to get the what? The signals, because you may put it here and you see signals are not coming out. Now, all that has some mathematical knowledge. There is mathematics behind it. And the angle at which you rotate matters. Those are gone some time back, the people had to rotate those dishes such that they get the clear what? Signal. Now this item is asking you, and which angle should you have to rotate such that your signal is clear? Something like that. That is the idea behind. So they are telling us that this engineer, they have this kind of model they have come up with. And what are they looking at? They are looking at, can you determine those positions of rotating the dish such that the communication is stable during one complete what? Rotation. Now that's what we are going to look at. And when they talk about one complete rotation, because they have told that the angle theta is the angle of what? Rotation. Now when you look at the angle of rotation, one complete revolution means, or one complete rotation means that you are going to come and rotate once. So they're asking, which positions should you place? Should you rotate? Should you rotate here? Should you rotate here? Should you rotate here? Should you rotate here? What are those positions? Which, when you rotate this thing, you can get clear signals. That's what we are going to be looking at. So, I think we are good to start. So indirectly, thank you, Alison. So here indirectly, they are telling you that your domain for theta is between 0 less than theta less than 360 degrees. When they tell you one forward rotation, it means that this is your domain. So instead of them giving you directly that your domain, your angles should be between 0 and 360, now this is going to be your domain. Okay, we are going to start. Now, when you look at the model they came up with, you notice that this model contains half angles. And in order for you to solve, you can never solve when these angles are not the same. That if you are dealing with double angles, let all angles be double. If you are dealing with single angles, all angles must be single within a particular equation. So we are going to solve. We have 2 cos of 2 theta plus 3 is equal to 4 cos of theta. Now, when you look at this equation, first take it into one term. Either let everything be in cos, let everything be in sine. But now here, since already this single cos is a cos, that means that the best choice to make is for me to take this cos to be in terms of cos. So you go back to your double angle. That when I have cos of 2 theta is the same thing as having 2 cos squared theta minus 1. That means that in the position where you have cos 2 theta, you are going to place that. So that means we shall come and write our cos 2 cos 2 theta plus 3 is equal to 4 cos of theta. So here we shall have 2 into 2 cos squared theta minus 1 plus 3 equaling to 4 cos of theta. Now what are you going to do? You open up your brackets. So that means you have 4 cos squared theta minus 2 plus 3 equaling to 4 cos of theta. Then this is where I'll ask you to continue from this point because negative 2 plus 3 is equal to 1 equals to 4 cos of theta. Then you notice, avoid things of crossing. Now already this is a quadratic what? Equation. So I'm going to write it like a quadratic equation and I'm going to ask you to continue from here such that everyone gets the answer. Can you continue from there? In case you get stuck, that's when I will come in to support. Renata? Unmute?
Yes.
Okay, Renata, can you take us from this point?
Within let cos theta be a letter, like
Okay.
y,
Mm-hmm.
and then we solve. Okay, we write 4y squared minus 4y plus 1 is equal to 0. Then we solve and solve for y.
Okay. Which method are you using?
Bulldozer.
Okay. So state it for us. Let me put here. I'm putting just here.
Yeah.
Okay, it is y is
Y
equal
is equal to negative b plus or minus root of b squared minus 4ac all over 2a. So y is equal to negative, then into brackets negative 4 plus or minus into brackets negative 4 squared minus 4 times 4 times 1 all over 2 times 4. So 4 plus or minus 16 minus 16 all over 8. So 4 plus or minus 0 all over 8. So the answer is a half. Y is equal to a half. Okay, so since, could you please first go back to the other screen? Okay, since cos of theta is equal to a half, then we find theta is equal to cos inverse of a half, which is 60. Then we draw the quadrant and we go to where cos is positive, which is the first and fourth. And we draw 60 there. And then our first angle will be 60. And our second will be 240.
Okay. Thank you, Renata. Renata, come back. How are you going to conclude? Okay. Okay, thank you, Renata. Billion.
Morning, sir.
Yes, morning.
Master, I have a simple question here.
Yes.
Master, after forming my quadratic equation, advisable or a correct method if I click it in the calculator, then I get to know that my answer is going to be positive half and positive 4. Then I just put my factors that m minus 0.5 into m minus 4 is equal to 0. Then I go to another either.
Now, that is where now the problem will come in. Because now m minus 0.5 and is it m plus what? You cannot have a factor like this. So that's why now when they know that you are forging. These factors come when something is like this. That's how they come about, when something is like this. That's when you get your m is equal to a half, but you cannot have m minus a half. Now, what you do for such case is when you say, like in case you get your factor as a half, then first multiply and know that this is 2m is equal to 1. So that means that your factor was supposed to be 2m minus 1, something like this. This is how you can go back, that in case your m was 5, then you say this is m minus 5, then that is how it can come about. Have you understood? Okay. Hope Billion you have got it. Holoman, then Favor.
Teacher, where did we get 240 from?
What is 240?
The next slide.
Hey, Favor, can you answer? Oh, no, Renata. Renata, I saw your hand. Renata, come back.
So I made a mistake. It's supposed to be 300.
It's supposed to be?
300.
Okay. Can you tell us how you have got that?
It's 360 minus 60.
Minus 60. Okay. Okay, thank you. Hope Billion is okay now.
Yes.
Okay. Yes, Favor?
Good morning, sir.
Morning.
That was the very concern I wanted to raise because we're all getting 300, yet we're seeing 240.
Oh, okay. Now, Favor, can you answer? Respond back to the task. How would you conclude?
I would conclude by saying, okay, let me first read the task. Determine all positions of the rotating dish at which stable communication occurs during one complete rotation. Hence, determine whether the automatic tracking system would achieve stable communication more than twice during the rotation. So first, the angles we got are 60 degrees and then the 300 degrees. So the positions at which the rotating dish would be stable are at 60 degrees and 300 degrees. And then lastly, since they're asking, hence determine more than twice, then we shall say no, it will not be more than twice during the rotation since we have only two angles.
Okay. What have you understood by twice? In the
Twice.
imagine this is your dish and this is your other one at this position and at this position. Within one rotation.
Within one rotation.
Okay. So you have said more than what? Twice. So when you read the word more than twice, what does it mean?
Oh, more than twice. Like more than. Okay, the once is 360, right?
Yes? Yes.
Yes. The once is 360. Then
Which
the
angle?
twice is 720. So, okay, I don't know. According to in my own understanding, maybe it is, if it would rotate, maybe more than 720.
Can we come back here? Come back here. This statement here.
Mm-hmm.
You said one
During
full
the
rotation.
test, the engineers observed that the communication signal repeatedly became stable at certain positions as the dish completed one full rotation. Then they needed to determine all the positions at which the dish would achieve stable transmission in order to correctly program the automatic tracking system. Okay, so can I get help from someone?
Okay. Joshua, you want to help?
Actually, I had a question, but then to send that, I think the tracking system would, okay, they want to determine whether the automatic tracking system would achieve stable communication more than twice. For my sake, it will not achieve stable communication more than twice, since it is only achieving stable communication at 60 and 300. Those are twice, and they are not more than twice.
Okay. Favor, what do you have to say? Have you had the response from Joshua?
Yes.
Okay, what do you have to say?
Okay, let me first. He said that here they said it only became stable after in one complete rotation, which means the domain was between 0 and then the 360, and then we only got two angles. So meaning, yeah, it will not be more than twice because it is only in one rotation, and yeah, according to me, that is it. I cannot go any further.
Okay. But what determines the stability? Because for the system to be stable, you are depending on the angle of rotation. So when you are rotating, this is where you can rotate. This is once, right? That's one rotation.
Yes.
Then that is once. Then if you are to rotate again, what is the second rotation? Is you going like this. Are those two?
Yes.
So now that is the kind, not the other domain you are thinking about.
Oh, okay. Yes.
Yes. But since here they said more than twice, that means that more than two. And here you have only achieved 2 times. That's the only way you can rotate that. You can either rotate it here or rotate it this side. So they are not more than 2.
Okay, thank you, sir, for the correction.
Okay. So that means that here the conclusion for Joshua is okay. Okay. Thank you, Fefa and Joshua. Yes, Joshua, you can now ask.
So my question was, so what do you call those quadratic equation whereby you're having one answer? Since we all know that a quadratic equation is supposed to have two answers.
Oh, no. Okay, now, quadratic equations are of different types. We have different types, eh? One, we have what we call perfect quadratic equations, or what we call perfect squares. Now, all perfect squares will always yield one answer. In other words, when you look at a quadratic equation, let me use a graph to explain that. When you look at a graph, when you draw quadratic, they are graphs of this nature. Now, these ones here, or a graph that will look like this. Are you seeing this? Whenever you have equations, let me say, give you equations such as x squared minus 2x plus 1 such, you'll find that those kind of equations have only one root. Here, they have only one x value, those equations that touch the x-axis. Now, those ones will give you one value. So, those ones are those equations that you'll get x minus 1, something like that. Those perfect squares, you'll get only one answer. Then you have those equations that when you sketch are going to be like this. Now this one still, when you check out the x value, they will give you this x value 1 and they will give you this. So they will give you two values. Hope you have understood.
Yes, I've got you, sir. Thank you.
Yeah, yes. So not all quadratics will give you two answers. It can be 1, it can be 2. But those which give you 1, it means that they are perfect squares. Yes, Daniela.
Teacher, for me, I was asking, I tried using bulldozer and factorization, but when I tried using factorization, where I got my sum was equals to 4 and my product was equals to 4, but
And
then
that's what was the equation? Members, we can be doing this item. It was 4 squared minus 4y plus 1.
Plus 1 is equal to 0.
What was your sum?
My sum was 4.
Negative 4.
And then my product was 4.
That is okay.
But teacher, trying substituting them into that, it's giving me a hard time.
First get, what are those two numbers? Which when you add, you get negative 4, you multiply, you get 4.
The two numbers which I add, I get negative 4 is negative 2 and negative 2.
Negative 2 and negative 2. So you would do 4y squared minus 2y minus 2y plus 1 is equal to 0. Then group this. So here 4y squared minus 2y, the common factor is 2y, into 2y minus 1. Here the common factor is negative 1. So you have 2y minus 1. So you notice that here now you have 2y minus 1 and 2y minus 1. Now 2y minus 1 to my 1 is the same thing. So that is the same thing as having 2y minus 1 equaling to 0, and then you get a half.
Okay, thank you, teacher.
What was your mistake? Which mistake were you making?
I made the mistake, substituting there after getting 4y minus 2y minus 2y plus 1, then getting that common factor there. It was giving me the hard time, but now I've seen.
Now what you do for those common factors, you can come here if you want, you can come here and then you do HCF. Which number goes here and here the same is y. So here you get 4, here you get 2. Which number goes here and here at the same time is 2. So here you get 2, here you get 1. Now this is your HCF that you are going to factor out, that I remove 2y. And once I remove with 2y, that means I remain with the 2 and I remain with 1, which is the 2 here and the 1 here.
Okay. Thank you, teacher.
Okay. Okay. Banner. Hope members are going through this item. Banner. Okay. I'll fail to get banner pixel.
Excuse me, sir.
Yes.
I'm requesting for the pardon of the conclusion of more than twice. I didn't get it well.
Oh, the conclusion was that the system since they told you more than twice, more than twice means that more than 2 times, eh? And yet the angles we got, we could only rotate twice. So that means that the system, they will not be able to achieve the stability they are looking at.
Okay.
Okay.
Thank you, sir.
All right. Pixel, or that was banner?
This was Pixel.
Okay. Banner?
Teacher, good morning.
Morning.
So teacher, I'm asking you to pardon me on Joshua's conclusion. I didn't get it.
Joshua, come back. Joshua?
Yes.
Conclude for them.
So can I please see that first? So the conclusion was the automatic tracking system would not achieve stable communication since during rotation, sorry, let me see. Hence, determine whether the automatic tracking system will achieve stable communication. So it was like the automatic tracking system will not achieve stable communication more than twice during the rotation, since it achieves stable communication only twice, which is at 60 degrees and 300 degrees.
Okay.
Have you understood?
Thank you, Joshua. Okay. So we have this. They are telling us that an engineer that is working in renewable energy, and for those who are into, one of the fields that is coming up is renewable energy. Those who are seeking scholarships in the future, there are a lot of opportunities in renewable energy. When you look at the many of the industries, they're giving out opportunities for someone who is into renewable energy. So engineers are working at Renewable Energy Research Center and they are testing some wind turbine systems. Now, after analyzing, the engineers proposed the mathematical relationship, which is there. During further testing, the monitoring system produced a vibration warning whenever that was there. So, when you look at the task, they're asking us that verify the validity of the engineer's proposed vibrational model. This is the model that the engineers proposed. So they are asking us for its validity. Now, when they ask the word validity means the logical correctness. Whether it is like here, the other simple word would have been proving. That prove that this one is equal to this. That is the meaning. In other words, whether an argument is correct, whether the proof is correct, that is the meaning. That if when you substitute in the value for x here is equal to this, that's what we call the validity of something, the logic. Hope we are together on that when it comes to validity. But when you are like building it up, you must be able to give like the reason, the logic flow must be there. So in other words, they're asking us that can we go on and prove this, that this side is equal to this side? That's what we are supposed to do. Now, why don't we start from here? How many members are saying that we complete the number or we can start from here tomorrow? Kindly let me know through the chat. Okay, members want us to complete. Okay. So we are going to prove it. So I'm going to allow me to first write it here. that it is cos 4x plus 4 cos of 2x. Okay, I'm going to go to a new screen. So it was cos of 4x plus 4 cos of 2x, and this one we must show that is equal to our 8 cos, this is what, 4x minus 3. Now, what do you do? Now, you are going to work, when it comes to verifying things, you can come from one side to the other, but always you'll find that there is a side that is much easier. There is a side that when you come from that side, things are going to be a bit much easier for you. Now, allow me that we are going to start from this side, from our left-hand side, and we are going to move towards the right-hand what? The right-hand side. Now, what are we going to do? We are going to have to build our angle. So earlier on, we say that when you have, this is cos of 4x, we say that for double angles here, we say that when we have a cos, this, we say that if this is our angle, x plus x, we say that this side, when we expand it, we can have our cos of x minus sine of x, sine of x. That is what we looked at first. Now, members, this was a single angle. Now, what about when we have cos of 4x? Which two angles, when we add, which two angles are we going to use for A plus B? Put for me in the chat quickly. Which angles are we using for that? Aha, very good. It is 2x. So we are going to come here and say 2x plus 2 of x. Now, you notice that from your knowledge of cos of A plus B, we are going to expand as cos of A, cos of B, minus sine of A, sine of B. So that means that our cos of 2x plus 2x is going to be our cos of 2x, cos of 2x, minus sine of 2x, sine of 2x. Now that means that where we have cos of x, this is what we are going to do. But we can now simplify this as cos squared of 2x minus sine squared of 2x. That means that where we have cos for x, we are going to substitute this. So when I substitute, I'm going to have from here cos of 4x plus 4 cos of 2x. So here I'm going to put, this is the same as cos squared 2x minus sine of squared 2x, then plus my 4 cos of 2x. Now what can I do? You are noticing that I have cos squared 2x, but where we are heading, our angle is single. So now here, members, I'm going to continue to simplify this further. But as I simplify, I need to first remove this. Are you seeing this 2x cos? Now, I want to bring to your attention, members, you know that cos squared of x plus sine squared of x is always equal to 1. But also, when we have a double angle, cos squared 2x plus sine squared 2x, members, also this is 1. As long as these two angles are the same. That's why when you place on your calculator, cos squared of 45 plus sine squared of 45, members, place for me, what do you get on your calculator? Place on your calculator, put it the way I've put it for you. Which answer do you get? Aha, you get 1. Even when you have cos squared of 90 plus cos squared of 90, this is sine squared of 90, members, which answer do you get on your calc? You are also going to notice that the answer is also going to remain with 1. Now, it doesn't matter. This angle here, as long as the angle is the same, it's going to be the same. But since I want to eliminate sine squared of 2x, I'm going to make sine squared 2x the subject. So that means that here, we shall have our sine squared of 2x equaling to 1 minus cos squared 2x. So now I'm going to come here and I say now, this is going to be cos squared 2x minus 1 minus cos squared 2x plus my 4 cos of 2x. So when I open the brackets, we shall have cos squared 2x minus 1 minus minus gives us a plus cos squared 2x, then plus 4 of cos of 2x. Now collect like terms. Cos squared plus cos squared will give us a 2 cos squared 2x minus 1, yes, plus 4 cos of 2x. Now back to our identities. We looked at the identity and we said, what is cos of 2x? And we say that cos of 2x is always given by 2 cos squared x minus 1. We did that. So when let me write it here, that when I have cos of 2x, we say this is the same thing as 2 cos squared of x minus 1. Now, members, still, even if we here, where we have cos 2x, we are going to replace this. So you are going to allow me that I'm going now to write this as 2. Now, this cos squared is the same thing as writing cos 2x squared minus 1, then plus 4 cos of 2x. So this is going to be 2. Now, where there is cos 2x, we are going to replace it with 2 cos squared of x minus 1. But everything is squared minus 1 plus 4. Where there is cos 2x, we still replace it with 2 cos squared of x minus 1. Now we are going to open the brackets. Now when you are opening here the brackets, I think I can write here, you have 2 cos squared x minus 1. And I'm multiplying it with 2 cos squared x minus 1. Open well. Remember this one multiplies everything here. So you say 2 cos squared of x into 2 cos squared of x minus 1 minus 1 into 2 cos squared of x minus 1. So when you open 2 times 2, you get 4. Cos squared times cos squared is cos of 4x. Then we come here. 2 cos times this is minus 2 cos squared of x. Open here, you end up with still with the 2 cos squared of x. Negative 1 times negative 1 is a plus. Now, negative 2 cos squared x minus 2 cos squared x is going to give you a 4. It's going to give you a 4. Minus 4 cos squared x, then plus 1. That is what I'm going to replace here inside. So I'll have 2, and everything here is 4 cos of 4x minus 4 cos squared x, then plus 1. Then minus 1, this 1, plus, open the bracket, 4 times 2 is 8, cos squared x minus 4. Now we open this bracket here, 2 times 4 will be 8, cos of 4x minus 2 times 4, which is 8, cos squared of x plus 2 minus 1 plus 8 cos squared x minus 4. What are you noticing? Now you are noticing that something is cancelling. You are noticing that this and this are the same. Then here you have 2 minus 1, that is a 1, minus 4, which is a 3. So that means that your answer here is going to end up having 2 cos 4x minus 3. And now that is how you show that now their model is valid, because the left hand side is equal to the right hand side. Yes. Okay. I'm going to answer a few questions. Yes or Twaj?
Now, sir, could there be scenarios? What if you calculate and it is not valid?
Then you conclude.
So there are scenarios like that?
Yes, they can test you. Then you conclude that,
Oh,
yeah.
oh, okay. Thank you, sir.
Okay. ZTE.
Excuse me, sir.
Yes.
Me, the problem is putting this that you've told us that cos squared 90 plus cos squared 90 in the calc. It's giving me an error.
You do it like this. Put cos 90. Then put a squared. Plus, put sine of 90. Put a squared. You have
Okay,
seen?
let me try it out. Yes, it gives me the answer.
Okay.
Thank you, sir.
All right. Okay. Okay. So I think for this scenario, we shall start from here tomorrow. So, yes, but I want you to try it out. You try it out. We have already done part one. We have already done part one. Now try out the next part, number two. Try out number three. I don't know. Oh, but wait. How can you go without an exercise? Wait. First take a screenshot. First take a screenshot of these beautiful numbers you are going to be trying out. Okay? Have members taken a screenshot? For such a number, like for part A, it was just a matter of you noticing that this was sine of 2 times 28. And then you know that 2 times 28 is the same as 56. Yeah, so that's what you had to do. Okay, hope you have taken a screenshot. Let me add you more. Okay, yeah. All right, so I'm going to stop sharing and I say, we shall continue from there. So you go, make sure you practice. And remember that for trigonometry, at least you need to go through every day for you to master
Excuse
them
me,
very
sir.
well. I beg that make
Excuse
sure
me.
that every day you go through. Yes?
Excuse me, sir.
Yes.
The other thing is that I'm not in the group.
Oh, maybe someone who has a link can support us with that. Anyone with the link, kindly share it. I shared it yesterday, but I don't know whether someone still has it. They can share it with us, but maybe you can send a message. We shall be able to add you. Okay. Okay, have a good day. See you tomorrow at the same time, 7. And I think tomorrow may be one of our last lessons, if not the last. Okay, I'm seeing some hands up. Let me